All right, just real quick, this is the unit circle sheet. This is both degrees and radians. On the back, I've got this picture with degrees one picture and radians in the other, and these answers aren't on there, right? So basically, these answers are within that sheet. But just to give you an idea of the stepping that I'm talking about, I'm going to step around here with this bar. This is, let's just start with cosine. Cosine is 1, cosine is the x-coordinate. So 1, smaller square root of 3 over 2, smaller square root of 2 over 2, smaller 1/2, smaller 0. Negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, negative 1. And then it starts going back the other way, negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, 0. It starts counting up again, 1/2, square root of 2 over 2, square root of 3 over 2, 1. Looking at this picture based on cosine, notice in the first quadrant, cosine is positive, first, fourth quadrant, cosine is positive because we're going to the right. The second and third quadrants are going left, cosines are negative. Looking at sine, same scenario. We start at 0, we get bigger, we're going up, right? So it goes bigger, half, bigger, square root of 2 over 2, bigger, square root of 3 over 2, bigger 1. Stays positive, it starts getting smaller, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. Then going negative, bigger, negative, you know, it's really getting smaller, but negative half, negative square root of 2 over 2, negative square root of 3 over 2, negative 1. They're in the third quadrant negative, they're below the x-axis, and then getting closer to 0, negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, and 0. My shadow's getting in the way there. But the whole idea there is that's how you memorize this. And if you visualize the picture, how many steps are you moving around the x-axis, then you're able to figure it out pretty quickly. All right. The reason it's important to memorize sine and cosine, and if you have those committed to memory, every other trig function can be related back to sine and cosine. So if sine is y and cosine is x, tangent is y over x. So for example, let's just take pi over 3 that we just did. We know that the wrapping function of pi over 3 was 1/2 and square root of 3 over 2. All right? That's the cosine and sine of that, right? So the tangent of pi over 3, according to this, is just y over x. Square root of 3 over 2 over 1/2. Multiply top and bottom by 2, you get the square root of 3. The cosecant is just 1 over sine. That'd be 1 over the square root of 3 over 2, which is just 2 over the square root of 3, which is just 2 times the square root of 3 over 3. Secant's 1 over x, 1 over 1/2, that's just 2. And cotangent is cosine over sine, that's 1/2 over the square root of 3 over 2. That's just 1 over the square root of 3, multiply top and bottom by 2. And then multiply top and bottom by the square root of 3, we get the square root of 3 over 3. So if we can figure out and memorize this cosine and sine of this, we can very easily create the tangent, cotangent, secant, cosecant. And just like that, we have that entire chart memorized just by memorizing the first 2 columns and knowing the relationship between sine and cosine and everything else. So that's the usefulness of this. And again, it creates speed, it creates a little confidence, you know, and just makes you all together feel more comfortable about trigonometry to have these committed to memory. So that's worth doing. Find the exact value of each function. Cosine pi over 4, sine of negative 7 pi over 6, tangent negative 5 pi over 4, secant 5 pi over 3. And again, all these can be found on your sheet. Okay? Try and do it from memory using the wrapping function idea, using the relationship between cosine and sine and tangent and secant. All right? To do it that way. Keep in mind that our sheet goes from 0 to 2 pi. Some of these angles aren't in the 0 to 2 pi realm, right? So pi over 4 is ready to go. So I'm going to put a little box around that. We're ready to do that one. Negative 7 pi over 6 can't do it, right? Because it's negative. We don't want negative angles. We're allowed to add 2 pi in the form of 2 pi. There's 4 pi over 2. There's 6 pi over 3. There's 8 pi over 4. And there's 12 pi over 6. This is over 6. We're going to add 12 pi over 6. That gets me to sine of 5 pi over 6. And now we're ready to go. Looking at tangent, negative 5 pi over 4. Again, negative 5 pi over 4 is negative, not good. We want it to be positive between 0 and positive 2 pi. Over 4 would be 8 pi over 4 is the same as 2 pi, so I'm going to add 8 pi over 4. That's going to give me tangent of 3 pi over 4. And finally, secant of 5 pi over 3. 2 pi is 6 pi over 3, so 5 pi over 3 is between 0 and 2 pi, so that's ready to go. So the 2 in boxes were ready to go to begin with. Now these 2 in boxes are ready to go now. All right, so basically I just want to find this, for A, I just want to find the cosine of pi over 4 and I'm done. All right. For B, I want to find the sine of 5 pi over 6 and I'm done. All right. The other two I have to find both sine and cosine because tangent is sine over cosine, so y over x. Secant is 1 over x, so we just have to find cosine and reciprocate it. All right, so again, get in the point here where you want to know what do I need to find. So if you just ask for cosine or sine, that's all you have to find. If you ask for tangent, it's sine over cosine. Secant is 1 over cosine. So know which one of the wrapping function pieces you need to know. Or you can find the whole wrapping function, just do with it as you please. All right, so pi over 4, again, if we imagine a unit circle, pi over 6 is here, pi over 4 is 2 steps up. So I want you to become comfortable with those radian values. If you know where they are, you're able to step it off. If you don't know where pi over 4 lives, how many steps am I supposed to go? So that probably is the most challenging part of this, is getting comfortable with that. And I just rattled it off the top of my head with, like I was counting 1 to 10 earlier, right? Because I've done it so often, and it's just that easy to me. As a junior in high school, it's just that easy to me. So it's not like, oh, I've taught for 23 years, plus I did some college, and no. As a junior in high school, it became that easy because I spent time and memorized that. All right. So pi over 4 is 2 steps. So this is cosine of equals 1, right? 1. So 1 step down, 2 step down. Square root of 3 over 2, square root of 2 over 2. All right. We move on to sine of 5 pi over 6. So again, we're at pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6 is right over here. And this is sine equals 0 right there, right? 0, and we're going 1 step up from 0, so that'll be positive a half. All right, if we look at 3 pi over 4, I skipped out on the way to 5 pi over 6, didn't I? All right, so pi over 4, or sorry, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4 is this one right here. Wow. 3 pi over 4. And if you look, sine equals 0 there, cosine is equal to -1, right? So I'm going 2 steps backwards from -1, so that's being negative square root of 2 over 2 for cosine. And I'm going 2 steps up from 0, 1/2 square root of 2 over 2. That's what I get for sine. So again, I get my cosine and sine values. Again, tangent is y over x, so I'm going to put the positive square root of 2 over 2 on top. I'll put negative the square root of 2 over 2 on bottom. And divide a number by itself, you get 1. Opposite signs give me a negative, so -1 is the tangent of 3 pi over 4. And finally, secant of 5 pi over 3. That had to go all the way to 5 pi over 3, didn't they? All right, here we go. So we're already at pi right here, right? Yep. So that's 7 pi over 6. That's 5 pi over 4. That's 4 pi over 3. 3 pi over 2. 5 pi over 3 lives right there. Okay. And 5 pi over 3, we're doing secant. That's 1 over cosine. So if I can find the cosine, I reciprocate it, right? So here's cosine equals 0. And I'm going 1 step to the right of 0, positive, so it's going to be positive 1/2. And if the cosine is 1/2, that means the secant of 5 pi over 3 should be the reciprocal of 1/2, which is 2. Could have brought that up earlier. But again, this is what's on the back of your yellow sheet. So maybe you have this memorized already, maybe you don't. But again, if you can't rattle that off just like you're counting, you know, and again, that's me. If you just look at these things here, this is 0, of course, right? Pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 3, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. Stumbled there towards the end, but those should just become commonplace. They're used so often, you see them all the time. That's just what they are. All right, and that works for me personally, but again, what works for you is up to you. The other way of memorizing these, if you wanted to make it easier on yourself to begin with, to know what they are, and then you have to change some stuff. You get everything a common denominator of 12. They go up one at a time. See? So, what do they go up? No, they don't, because that's 0, 2, 3, 4, 6. Yeah, I guess it skips a couple. Pi over 12 and 5 pi over 12 skips. That's probably easier that way. Okay, just go with the memorize the order the way they are. That's probably the best. But again, if they're starting to ask you for exact values, I want you to start trying to do it from memory. Figure out the cosine, figure out the sine, or both, and then use cosine to find cosine, sine to find sine, both to find tangent and cotangent, specific ones to find secant or cosecant, and do it that way. And again, refer back to your sheet to get the right answer. If you're wrong, fix it, and then try and fix your memorization. But the quicker you do this, the better off you're going to be.